Have you ever wondered how OOP's class access modifiers and non-access modifiers work in real life? Well, get ready for a fascinating journey into the world of object-oriented programming, where we will demystify these concepts for you. In the realm of object-oriented programming, or OOP for short, access modifiers and non-access modifiers play crucial roles. They're like the backstage crew in a theater production, working behind the scenes to ensure that the performance runs smoothly. These unsung heroes of the programming world may not always be in the spotlight, but they significantly influence the overall functioning of the program. First, let's talk about access modifiers. Imagine you're throwing a party. You've got the guest list, right? Now, who you allow into your party, that's essentially what access modifiers control in OOP. They determine who gets to access the class members, or in our party analogy, who gets to join the fun. The level of access can vary. Some guests might have full access to all areas, while others might be restricted to certain parts of the venue. Now, let's move on to non-access modifiers. These guys are like the rules of the party. They dictate what the guests can and cannot do. For example, they might specify that guests can't bring their own drinks or that the music can't be too loud. In the same way, non-access modifiers provide additional functionality in OOP, defining the behavior of the class members. So, in a nutshell, while access modifiers control who can access class members, non-access modifiers dictate how those members behave. These two types of modifiers work together, like the gears in a well-oiled machine, to ensure the smooth functioning of our OOP system. Now that we've laid the groundwork, let's delve into some real-life examples of how these modifiers work. Prepare to see how these backstage heroes of programming come to life in the real world as we unravel the mysteries of access and non-access modifiers in the subsequent scenes. Enjoy the ride! Imagine you're in a library and you see a book on a shelf. That book is like a public class member. Let's delve into this analogy to better understand public access modifiers in object-oriented programming. A library, a common place of knowledge, is open to everyone. Anyone can walk in, pick a book from the shelf, and start reading. The books are accessible to everyone, irrespective of who they are or where they come from. Similarly, in the realm of programming, a public class member, be it a method or a variable, is like that book on the shelf. It's open for everyone, accessible from any other class in the program. Imagine a class in your program as a library, and the members of the class as books. When a member is declared public, it's like placing a book on a shelf in the library. Just as any library visitor can reach out and grab that book, any other class in your program can access that public member. This unrestricted access can be powerful, but it should be used judiciously. Just like in a library where books can be misused or damaged if there are no rules in place, in programming too, providing unrestricted access to class members can lead to unintended consequences. But don't worry, programming languages provide us with other access modifiers for those situations where we need more control over who can access what. We'll explore those in the upcoming scenes. Remember, access modifiers are all about setting boundaries, about defining who can access what, and the public access modifier? It's the most welcoming of them all, opening the gates wide for any class to interact with the members it is applied to. So, in essence, a public class member is like a book in a library available for everyone to access. Just as the library democratizes knowledge, the public access modifier democratizes access to class members, making programming a bit more like a communal journey of discovery. Now, think about your personal diary. That's similar to a private class member. Just as your diary is a collection of your most intimate thoughts, feelings, and experiences, a private class member holds specific data or functions that are exclusive to its class. You wouldn't want just anyone to have access to your diary, would you? Similarly, the private access modifier ensures that the class member is only accessible within its own class. Imagine it this way. Your diary is locked inside a special box and you're the only one who has the key. No one else can open it or read it. They can't even see what's inside it. This is how a private class member functions in object-oriented programming. It's safely enclosed within its class, and only that class has the key to access it. This is a critical aspect of encapsulation, one of the 4 fundamental principles of object-oriented programming. Encapsulation is all about bundling data and methods that operate on that data within one unit, and controlling access to it. By declaring a class member private, we are effectively encapsulating that member, preventing any outside access. Let's consider a real-world application of this concept. Say you're developing a banking software. You'd have a class for bank account, and within this class, you'd have members like account number, balance, and password. Now, you wouldn't want these details to be accessible to just anyone, right? So you'd declare them as private. This way, they can only be accessed and modified within the bank account class, ensuring the security of the account details. In conclusion, private access modifiers help maintain the integrity and security of our data. They allow us to control who can access and modify our class members, much like how only you can access and modify the contents of your personal diary. So, a private class member is like your personal diary, only accessible to you. Just remember, it's not about keeping secrets, it's about maintaining control and ensuring security. That's the essence of a private access modifier in object-oriented programming. Ever seen a no entry sign on a door? That's quite like a non-access modifier. Let's break it down. Think of a door with a no entry sign. This sign doesn't control who can see the door or who knows about the door. It's not about visibility, it's about interaction. It dictates the rules. You can't go through this door. In the same way, non-access modifiers in object-oriented programming don't control who can see or know about a class or its members. Rather, they change the way those class members behave or interact. Consider the final non-access modifier. When you declare a class as final, it's like saying, this is it, no changes allowed. You can't extend a final class. It's a class with a no entry sign for other classes that might want to inherit from it. Then we have the static non-access modifier. Imagine a door that leads to a common room in a hostel. No matter which student uses their key, the room remains the same. That room is like a static member of a class. It doesn't belong to any one instance of the class, but to the class itself. And what about the abstract modifier? That's like a door marked emergency exit. You can't just saunter through it on a whim. It's meant to be used in specific circumstances when there's a real need. An abstract class is similar. You can't just create an instance of it, it's meant to be extended to provide a blueprint for other classes. Remember the synchronized modifier? It's like a door with a security guard. Only one person can pass through at a time to ensure safety. In the same way, synchronized methods allow only one thread to access them at a time, maintaining the integrity of the data. So, a non-access modifier is like a no-entry sign, dictating the rules of interaction. And just like how different signs serve different purposes, each non-access modifier has its own unique role in shaping the behavior of our classes and their members. So, we've taken a journey through a library, peeked into a personal diary, and come across a no-entry sign. Quite an adventure, wouldn't you agree? This journey, my friends, was no mere sightseeing tour. It was, in fact, a deep dive into the world of access and non-access modifiers in object-oriented programming. Let's take a moment to revisit and reflect on the key takeaways. We began with the public access modifier, symbolized by our open library. Just as anyone can access the books in a library, a public access modifier allows class members to be accessed from any other class. Next, we ventured into the realm of private access modifiers. We compared this to a personal diary, a place where contents are meant for the eyes of the owner alone. Similarly, in OOP, private access modifiers restrict access to class members exclusively to the class in which they are declared. Finally, we encountered the no entry sign, our analogy for non-access modifiers. These modifiers don't control access to class members, but dictate their behavior and characteristics. They're like the rules of the road, providing guidance and restrictions that help prevent programming accidents. Understanding these concepts is not just about learning the syntax or memorizing definitions. It's about grasping the underlying logic, the principles that guide how we structure and interact with our code. It's about appreciating the elegance and power of OOP, where complex systems can be modeled using classes, objects, and the relationships between them. In the end, it all comes down to control and clarity. Access modifiers control who can interact with our class members, and non-access modifiers provide clarity on how those interactions can take place. And just like in real life, these rules and restrictions exist to create order, maintain privacy, and ensure that everything works as intended. Remember, just like in real life, in programming too, The access and non-access modifiers guide us on how we can interact with class members.